Hello dear students, today I am going to discuss a very beautiful problem from Pathfinder book जिसमें मिक्स कंसेप्ट है आपका कर्विलिनियर ट्रांसलेशन मोशन एंड न्यूटन्स लॉज ऑफ मोशन. सो मैं क्वेश्चन को शेयर करने जा रहा हूँ. दिस इज गिवन इन द न्यूटन्स लॉज ऑफ मोशन चैप्टर ऑफ पाथफाइंडर बुक. सो आई थिंक आप लोग पहले से इसको देखे होंगे. स्टिल जो जिन लोगों ने ट्राई नहीं किया होगा पहले से, यू कैन गिव योर अटेम्प्ट and pause the video, and after that you can go through the solution. So I am going to solve this question. The question is, a rod of mass m, length L is suspended from the ceiling with the help of the two light inextensible cord, each of length L, so that the rod is horizontal. Starting, it is given that the rod is horizontal. The rod is given an angular velocity omega about its central vertical axis, which is given in this diagram. Find the increment in the tensile force in a cord immediately after the rod is given angular velocity omega. So say what we can say, this is the initial situation. When rod is in this position, like this, and this is the support, and this is the support. When rod will try to rotate like this, then this is string or rope, whatever it's given, is going to be twisted like this. So in order to that, it will deviate by certain angle, say just after releasing the rod, after giving this angular velocity, it will have tendency to this end to go in this direction and this end will go to this direction, due to which this end is constrained to move in this direction, because it will, this portion of string will constrain, it will become taut. So in order to that, it will lift somewhere because this is going to be deviated. So on the both the ends, the same situation is going to happen. So say I am going to take, this situation is like this, this portion is like this, and say this end is go in this direction. So say this situation is like this. And rod is like this, you can say. At this location, rod, I am writing it with the bold line. So rod is like this, and say it is rotated by a very small angle theta. So this line, this arc length, you can say, because this is the rod, it is going to rotate like this. So this arc length will be angle times this radius. But since this string is going to be tilted, so this portion will lift. If this rod becomes horizontal, then it could have rotated in this horizontal plane like this. Still it will rotate, but it will lift simultaneously due to this constraint of a string or rope. So what we can say, this portion can be written as this L by 2 times theta, because this length is L by 2. So this will be rotated by this. And say if this angle is alpha, then, and this length was given as a L, then what we can say, simultaneously this is equals to L times alpha also. So from here, if we calculate the value of alpha, then this will be L by 2 times 2L times theta. We can say this. Now we can think about the curvilinear motion concept, in which if any velocity vector is changing its orientation, then how we write the acceleration. Because here this end is moving with omega L by 2 just after release, but since it is constrained, rope will lift it, means during the course of rotation, simultaneously it will be tilted at this angle of alpha. So the change in velocity will be due to changing orientation, not in magnitude, because just after release it will change its orientation. So this is the case of changing orientation of the velocity vector. Like we have seen, if you have written v vector as v mod v roof, those who have attended the class, they can write the acceleration vector easily. So if only v roof is changing, so this was coming nothing but mod v times omega minus v roof perpendicular, if you remember, जिसको हम लोगों ने माइनस आर रूफ भी बाबू लिखा था. So similarly, here velocity was in this direction and it is lifted like this. So change will be along the string only, isn't it? Because this is the direction of omega L by 2 and it is lifted like this. So this will be the change, and this change is along the string only. So what we can write, if this is your omega L by 2, but since it has lifted at angle alpha, here I have taken as alpha, so this change occurs along the chord, along this chord, means along the tension. So, and this can be written as, according to this concept of curvilinear motion, this acceleration vector can be written as omega L by 2 times rate change of this angle, and here if we find the rate change of this angle, then this will be this times d theta by dt, which is given as omega. So this is nothing but omega L by 2 times, if you substitute this value, then this is coming L omega by 2L, which is coming omega square L square by 4L. So now if we write the force equation, then what we can say here now, if suppose tension becomes T plus delta T in both these strings, T plus delta T, then you can write along chord net force can be written as T plus delta T for both the string. Since it is tilted by angle alpha from the vertical, so component of mg will be mg cos alpha is equals to mass times acceleration. That acceleration is due to this changing orientation of velocity vector, and that is coming along this string only. So this can be written as mass times omega square L square by 4L. Initially we have 2t value when this rod is horizontal. At that time this was mg itself, and here we have to find immediately after the rod is given an angular velocity. It means just after release we have to find, means this theta and alpha will be very small. So what we can write, mg cos alpha value is nothing but approximately equals to mg only, because this alpha is very small. So if we solve this value, 2t plus 2 delta t minus mg cos alpha is equals to m times omega square L square by 4L, then these 2t and this get cancelled. So delta t value we are getting m omega square L square by 8L. So this is the required solution. So ये मेथड आपको कैसा लगा? थ्रू योर कमेंट जरूर से बताइएगा.